24, this is where we are going to, we'll directly use the U substitution because it'll help, but hopefully you're seeing we're going backwards and forwards between taking a derivative and, you know, that the inside, the derivative, I don't know how to do this, but that whatever's in here is the derivative of something. I guess maybe we go this way. Look at this. Yeah, we'll go this way. That whatever in here is the derivative of something, and so we could kind of go back and forth. Integration is underivatizing, whatever that's. I don't know if that's a word. And then whatever's in here is you know, taking the derivative. So we've got the derivative. Maybe I'll just do it in words. The derivative is connected with the integral. And actually in math, it's usually some kind of a triangle. We have this function that we can take its derivative, and then that derivative, when we integrate it, takes us back to the original function. So maybe that makes sense. The function goes, we take its derivative, we've got that, and then when we put it in and integrate it, we're back to the function. So it's kind of this circular thing that's going on. A lot of times we need to look back to the derivative. We've got this process for taking a derivative is very straightforward. Integration, remember, is like looking in the rear view mirror. Everything seems kind of backwards, and it takes some time to switch, and you've got to go through things in a reverse order. Okay, with that being said, let's go ahead and just take a look at this. We've got an inside part that involves a y to the 9th. Remember, if we took this derivative, we'd have a y to the 8th. Ooh, cool. We've got a y to the 8th outside of this thing, which looks like part of a derivative. Okay. Now, to match all the pieces up, what we do is we use this little technique called U substitution. And I guess maybe you, because you are the one doing the substitution. You are in control. And what we have to be able to do is spot inside and outside. So I'm going to, you know, emphasize we're inside the radical here. And in a moment when we rewrite this, we're going to make this to the 1/2 power, because that's really how we're going to be able to integrate it. What we want to do is whatever the inside is, that's what we want to make our u. Again, you choose. 9 minus 2y to the 9th. And I remember learning all of this. My biggest problem was choosing the wrong thing for u. I might try the whole square root thing or something, or maybe I'd make it 2y to the 8th, but that's the wrong thing to choose, because it's not going to help. You take its derivative, it's going to be 7, and there's no y to the 7th. Okay, so what we are at right now, as we start to make our substitution, so this 9 minus 2u is going to become just, or 9 minus 2y to the 9th just becomes u. And instead of the radical, we're going to put it as a 1/2 power, because that will help us take its integral to integrate it. Okay, so we've got that part. Now look, we got these other parts here. So remember, to get this, we have to take the derivative of both sides. Derivative of u is du. This side, derivative of 9 is 0. Derivative of negative 2y to the 9th, the 9 comes down, so we get minus 9 times 2 is 18, y to the 8th, and we took the derivative with respect to y, so that's a dy, not a duy, yeah, one of those things, just a dy. DIY is what, do it yourself? Yeah. But also we are doing it ourselves. So then what we do is, just to kind of emphasize, we divide by negative 18y to the 8th, because what we want to know is, we want to substitute, because we got this dy right here. 18 y to the 8th. Okay, so that's going to be the substitution we make there. So instead of dy, so notice this cancels, this cancels. This is now dy equals this whole monstrosity, so we write that in there. Y to the 8th. And what we have left over, here we go, is this 2 y to the 8th is still there. Okay, we didn't do anything with it, right? That was, again, always the hardest part for me. But now what we can see is, well, okay, I've got a y to the 8th divided by y to the 8th. That's 1. And then I could reduce this. I've got the 2 is in the numerator, 18 is in the denominator. So 2 goes into both of these, leaving 1 there and negative 9 here. Okay, so let's go ahead and write what we actually have, the u substitution. What has it done for us? Well, this is all gone. We have u to the 1/2 du, and it's over negative 9, so that's like 1/9. What do you mean, like? It is. Okay, okay, gotcha. So there's negative 1/9. Now we've got something that's so much more beautiful to work with. It's simple, it's artistic. Okay, maybe not. But I'll tell you what, I like it a lot better than that. So what do we do to integrate? Well, it's just a u, a simple little ordinary u to the 1/2 power. We add 1 to it. Now remember, when we add 1 with a fraction, use its common denominator. So we're going to add 2 over 2. Okay? And then when we do that, we get u to the 3/2, and we have to divide by that, the new exponent. Since we don't have limits, we get plus a constant, and this constant multiplier out front is still there. Okay, now it's just a matter of cleaning it up a little bit, because we're dividing by a fraction. Remember, when you divide by a fraction, what we really do is we can take its reciprocal, so 3/9 becomes 2/3. And again, we could do it on this side, it might make more sense, but because we're dividing by this, we multiply by its reciprocal. Okay, so it's not that we're canceling this out, it's just we took this, because when you have two fractions, so let me change colors and just kind of make it clear what I'm doing here. This is really u to the 3/2 divided by 3/2, so it's u to the 3/2 times 2/3. That's where this 2/3 is coming from. And I just moved it to the front, just say let's put all the fractions together and let's multiply them. That's where this comes from. It's not, so this is really gone. It's transformed itself by operationally saying, okay, division is multiplying by its reciprocal. Okay, and then so what we do is, okay, that's gone. Well, it's not really gone. It came over here. All right. 2 times 1 is 2. 3 times 9 is 27. We got that negative. We get u to the 3/2 plus a constant. And then we just do this back substitute thing where we created the u. That was us. We invented something, but what is it? It really is 9 minus 2y to the 9th, because what we want is something here. So what we're going to do is take our answer and back substitute what u really is in terms of y, right? Again, those are all words that kind of just flow together and don't really mean much at a heart level, but I know how to execute it, right? And we'll put this to the 3/2. 3 times 1 is 2. 3 times 9 is 27. We got that negative. We get u to the 3/2 plus a constant. And then we just do this back substitute thing where we created the u. That was us. We invented something, but what is it? It really is 9 minus 2y to the 9th. So what we're going to do is take our answer and back substitute what u really is in terms of y, right? Again, those are all words that kind of just flow together and don't really mean much at a heart level, but That's a beautiful answer, just as it is. Do we need to use I mean, we could go back with a radical. There's a lot of things we could do with algebra, but I don't see any real reason to. You could put this 27 underneath everything if you want, but it doesn't reduce. It's all good. It's all good. Now, you could also take its derivative just to make sure you get back to what you started with. But I tell you, it's a test. It's got limited time, right? You want to, if you do this all carefully, you'll see, you'll have convinced yourself that this is the correct answer. Although I sometimes leave off a negative or something, but I'm getting better at doing that. Okay, so backwards, forwards, forwards, backwards. Thank you.